Good morning, students. Today we are going to discuss some of the differentiation questions from the NCERT textbook. Class 12. Y equals to sin ax plus b. Differentiating with respect to x. It is a function of functions, so we have to take ax plus b is equals to t. So d by dx of sin t is equals to d by dt of sin t into dt by dx. D by dt of sin t will become cos t, and d by dx of t value is ax plus b. So cos t value of t ax plus b, and differentiation of ax plus b will be ax का differentiation हो जाएगा a d by dx of x 1 and d by dx of constant quantity b will become equal to 0. That is a cos ax plus b. Next, y equal to cos root x. Here root x we have to take it as t. So d by dx of cos root x, d by dx of cos t, d by dt of cos t into dt by dx minus sin t into d by dx of root x is 1 by 2 root x, and we substitute the value of t here in the sin function, minus 1 by 2 root x sin root x. Now comes next, y equals to ax plus b sin ax plus b upon cos cx plus d. It is the divide function. So cos square cx plus d denominator square equals to second function into differentiation of first function minus first function into differentiation of second function. So here differentiation of sin ax plus b will become cos ax plus b into a, and d by dx of cos cx plus d will become minus of sin, that's why it will become minus plus sin of cx plus d into cx plus d ka differentiation c. Now here if we can separate it out, cos cx plus d and 1 of the cos cx plus d will be cancelled out, and the denominator there is 1 cos cx plus d is left out. So it will be 1 upon cos cx plus d will become sec cx plus d, and rest is a cos ax plus d. For the second one, if we divide sin cx plus d upon cos cx plus d, we get tan cx plus d, and 1 of the cos cx plus d denominator is left out, that become sec cx plus d and c into sin ax plus b in the numerator as it is. Now next, y is equals to 2 under root cot x square. It is a function of function. Differentiating with respect to x, dy by dx equals to 2 into d by dx of under root cot x square. This cot x square complete function we are going to take it as t. So d by dx of root t into dt by dx, 2 d by dx of root t. This will be d by dt of root t. D by dt of root t will become 1 by 2 root t, 2 and 2 cancel, and d by dx of cot x square. Now x square we have to take it as, again here coming as function of function, so x square will take it as u. So 1 by replacing the value of t, cot x square, d by dx of, this is cot u, not cos u, cot u, and d by dx of cot u will again d by du of cot u into du by dx. So d by du of cot u will be minus cos x square u, d by dx of x square 2x. Now just we have to do the arrangement of the terms. 1 upon under root cot x square will become under root tan x square, which can be written as minus under root sin x square upon under root cos x square. This cos x square can be written as 1 by sin square x square. This is 2x, and we are multiplying dividing with root 2 minus under root sin x square. This sin square x square can be written as under root sin x square under root sin x square into sin x square. So one of the under root sin x square cancel out. This root 2 and this under root sin x square, this under root cos x square can be taken in 1 under root. So it becomes 2 sin theta cos theta, and 2 sin theta cos theta is sin 2 theta, that's why it becomes sin 2 x square, and rest of the quantities are same. So our final answer will be minus 2 root 2x upon sin x square under root sin 2x square. Okay. Now let's come to the next question. If y equals to 1 upon 1 plus tan x, differentiate it with respect to x. So it is again u by v divide rule. 1 plus tan x the whole square equals to second function to differentiation of first function minus first function to differentiation of second function. So d by dx of constant is 0, so this value will be vanished down. D by dx of 1 is 0, d by dx of tan x x square x minus x square x upon 1 plus tan x the whole square. If y equals to cos log x plus e to the power x, differentiate with respect to x. We can't open the bracket and take it as cos log x plus cos e to the power x. This complete log x plus e to the power x, we have to take it as t variable. So it becomes cos t, d by dt of cos t minus sin t, dt by dx में आ जाएगा d by dx of in place of t log x plus e to the power x. Now we can differentiate these two functions. D by dx of log x, which is 1 by x, and d by dx of e to the power x is e to the power x. Now the next important question, if y is equals to log tan pi by 4 plus x by 2, find dy by dx. So this complete tan pi by 4 plus x by 2, we are going to take it as t. It becomes d by dx of log t. So d by dt of log t into dt by dx. D by dx of log x is 1 by x. So d by dt of log t will be 1 by t. D by dx of value of t is now tan pi by 4 plus x by 2, substituting here. And this now pi by 4 plus x by 2, we are going to take it as equals to u, so that it will become tan u. Now d by du of tan u into du by dx. But d by dx of tan x is sec square x, so d by du of tan u will become sec square u into d by dx. U is pi by 4 plus x by 2. So t value is our tan 1 upon tan pi by 4 plus x by 2. Sec square u is our pi by 4 plus x by 2, and d by dx of constant pi by 4 will become 0, and d by dx of x by 2 will become 1 by 2. Now just the simplification of the trigonometricals. 1 by tan will become cot, and cot will become cos by sine. This sec square will become 1 by cos square, as it is 1 by 2. So cos pi by 4 plus x by 2, cos pi by 4 plus x by 2, one of that cancels. So 2 sin theta cos theta का format आ गया. 2 sin theta cos theta is sin 2 theta. So it becomes sin 2 into pi by 4 plus x by 2, and 2 will be multiplied inside the bracket. It will become sin pi by 2 plus x. And sin 90 plus theta is cos theta. So it becomes 1 by cos x, and 1 by cos x is sec x. Now here comes the next question. If y equals to under root over sec root x, find dy by dx. So it is also a function of function. So first we are going to take sec root x is equals to t. It will become root t, d by dt of root t into dt by dx. D by dx of root x is 1 by 2 root x. So d by dt of root t will be 1 upon 2 root t. D by dx of in place of t sec root x. Now root x we will take it as equals to u. 1 by 2 root t, it will become d by dx of sec u. So d by du of sec u into du by dx करेंगे. 1 by 2 root t d by dx of sec x is sec x tan x. So d by du of sec u will be sec u tan u into d by dx of in place of u will replace root x. So 1 by t value is sec root x under root sec root x. U is root x, so sec root x tan root x, and d by dx of root x is 1 by 2 root x. So at last the final answer will be sec root x tan root x, 2 into 2 4 root x under root sec root x. Now the next one is y equals to under log under root 1 plus sin x upon 1 minus sin x. This root can be written as 1 plus sin x upon 1 minus sin x whole to the power 1 by 2. As we know the logarithmic formula, log n to the power n equals to log n log n. So this 1 by 2 will become the coefficient 1 by 2 log 1 plus sin x upon 1 minus sin x. And log n by n is equals to log n minus log n. So it will become 1 by 2 log 1 plus sin x minus log 1 minus sin x. Now differentiating with respect to x. D by dx of log 1 plus sin x, d by dx of log 1 minus sin x. So 1 plus sin x will be the same way, we will take it as a t, and d by dt of log t will become 1 upon t. So it will become 1 upon 1 plus sin x, and d by dx of 1 will become 0, and d by dx of sin x will become cos x. And d by dx of log 1 minus sin x, again this function 1 minus sin x we can take it as t. So d by dt of log t will become 1 upon t, and t is our 1 upon 1 minus sin x. So 1 upon 1 minus sin x हो गया, और और d by dx of 1 0 हो गया, d by dx of sin x minus cos x हो जाएगा। अब cos x और cos x कॉमन ले लेंगे और ये माइनस और माइनस प्लस बन जाएगा, एंड डिनोमिनेटर 1 plus sin x 1 minus sin x, their product will become the LCM. So 1 minus sin x plus 1 plus sin x minus sin x plus sin x cancels, 1 by 2 into cos x 1 plus 1 2, a plus b into a minus b, a square minus b square, that will become 1 minus sin square x, and 1 minus sin square x is cos square x. So one of the cos x and this 2 is cancelled out. So 1 upon cos x is the final answer, will be our sec x. Now it comes to a differentiation of the inverse trigonometric functions. Y equal to sin inverse 2x. In the same way we have to differentiate it, but now we have to apply the differentiation formulas of the inverse trigonometric functions. So d by dx of sin inverse 2x, it is a function of function. So 2x को t लेंगे, d by dx of sin inverse of t will become d by dt of sin inverse of t into dt by dx. So d by dx of sin inverse x is 1 upon under root 1 minus x square. So d by dt of sin inverse t will become 1 upon under root 1 minus t square. dt by dx as t is 2x. So d by dx of 2x, it will become 2 upon under root 1 minus t square, and t is 2x, so it will become 2 upon under root 1 minus 2x the whole square, 4x square. Next one, y equal to tan inverse sec x plus tan x. ये एक इनवर्स ट्रिग्नोमेट्रिक फंक्शन प्रॉब्लम है जिसे हमने इनवर्स ट्रिग्नोमेट्रिक फंक्शन चैप्टर में सॉल्व किया है. सिंप्लीफाई फर्स्ट ऑफ ऑल द इनवर्स गिवन ट्रिग्नोमेट्रिक फंक्शन इन द सिंपलेस्ट फॉर्म. सो फर्स्ट वी आर सॉल्विंग, वी आर नॉट डिफरेंशिएटिंग हियर. y equal to tan inverse 1 by cos x sin x by cos x 1 plus sin x upon cos x. tan inverse sin x को चेंज कर सकते हैं कॉम्प्लीमेंट्री में cos 90 minus theta, और cos x को चेंज कर सकते हैं कॉम्प्लीमेंट्री में sin 90 minus theta. 1 plus cos theta is 2 cos square theta by 2. So that's why 1 plus cos pi by 2 minus x will become 2 cos square pi by 2 minus x divided by 2, which will give you pi by 4 minus x by 2. In the same way, sin theta 2 sin theta by 2 cos theta by 2, so it will become 2 sin pi by 4 minus x by 2 cos pi by 4 minus x by 2. One of the cos pi by 4 minus x by 2 will be cancelled out, 2 and 2 also cancel out. Cos by sin will become cot, and cot can be converted into a tan. Since there is outside there is a tan inverse, by making it the complementary form tan 90 minus theta. The simplest form gives us pi by 4 plus x by 2. Now we can differentiate with respect to x. So dy by dx equals to the differentiation of constant value is 0, and differentiation of x by 2 1 by 2 will be taken out of the differentiation, and d by dx of x is 1. So 1 by 2 into 1 is 1 by 2. Now next, y equal to sin tan inverse e to the power minus x. This complete function I am going to take as t function. So dy by dx equal to d by dx of sin t. So d by dt of sin t will be cos t, and dt by dx value of t is tan inverse e to the power minus x. Now d by du of tan inverse of u e to the power minus x, I am going to take it as equals to u. So d by dx of tan inverse x is 1 upon 1 plus x square. So d by du of tan inverse of u will become 1 upon 1 plus u square, and du by dx as u is e to the power minus x. So d by dx of e to the power minus x is minus e to the power minus x. So this minus comes in the front, cos tan inverse t value tan inverse e to the power minus x into 1 upon 1 plus u square. U to the u square means e to the power minus x ka square will become e to the power minus 2x into e to the power minus x. So that is our answer. Now if y equals to tan inverse x sin alpha upon 1 minus x cos alpha, find dy by dx. Here you can see that if we are going to differentiating with respect to x alpha, this is not x, this is alpha, sin alpha and cos alpha is their constant values. So dy by dx equals to d by dx of this complete function I am going to take it as t. It becomes tan inverse of t, d by dt of tan inverse of t into dt by dx. d by dx of tan inverse of x 1 upon 1 plus x square, so it will become 1 upon 1 plus t square. So d by dx t x sin alpha upon 1 minus x cos alpha. This is u by v. So v square first function to differentiation of second function minus first function to differentiation of second function. So 1 upon 1 plus t square 1 minus x cos alpha d by dx of x sin alpha. Sin alpha will be taken out of the differentiation. It is not a product function. Sin alpha को बाहर ले लेंगे differentiation के और d by dx of x क्या हो जाएगा 1. X sin alpha d by dx of 1 will be 0. In the same way x cos alpha, here cos alpha is a constant coefficient of the x. So cos alpha को बाहर ले लेंगे differentiation के तो cos alpha d by dx of minus of x minus 1, so it become minus cos alpha. After opening the brackets and substituting the value of t, here x sin alpha the whole square upon 1 minus x cos alpha the whole square. After simplification, we get to the final answer sin alpha upon 1 minus 2x cos alpha plus x square. Now question number 14, this is just a 1 mark question, important. If y equals to sec inverse of x plus 1 upon x minus 1 plus sin inverse of x minus 1 upon x plus 1, find dy by dx. Sec inverse of x plus 1 upon x minus 1 and this is sin inverse x minus 1 upon x plus 1. If we take the reciprocal property that we have studied in the inverse trigonometric function chapter, so sec inverse of x plus 1 upon x minus 1 can be written as cos inverse of x minus 1 upon x plus 1. This angle will be reversed. So this angle is also same, this angle is also same, and as we know that in inverse trigonometric function cos inverse x plus sin inverse x is equals to pi by 2. So cos inverse of x minus 1 upon x plus 1 plus sin inverse of x minus 1 upon x plus 1 will become pi by 2 and constant pi by 2 differentiation will be 0. Next question, if y equals to cos inverse of x upon x plus 1, find dy by dx. Differentiating with respect to x, this function will be taken as a t. D by dt of cos inverse t, d by dx of cos inverse x is minus 1 upon under root 1 minus x square. So it will become minus 1 upon under root 1 minus t square d by dx of x upon x plus 1, as the t is x upon x plus 1. Again comes the u by v differentiation. We will differentiate it and simplify it and we will get the final answer minus 1 upon x plus 1 under root 2x plus 1. Now let's move to the next question. Differentiation by the trigonometrical substitution. We have done in the inverse trigonometric function chapter. As there is x square plus 1, so x equals to, we take tan theta, 1 minus x square is there, x equals to sin theta or cos theta, or 1 plus x, 1 minus x, then x equals to tan theta. If it is under root over 1 plus x or 1 minus x, we take x equals to cos theta. All those fundamental concepts I have given in the inverse trigonometric function. It is just like the problem of an inverse trigonometric function. To simplify them first in the simplest form, get its simplest form as we are getting the inverse trigonometric function chapter, and then we have to differentiate it. So y equal to sin inverse 2x upon 1 plus x square. If we take x equals to tan theta, 2 tan theta upon 1 plus tan square theta will become the formula of sin 2 theta. इसके लिए सभी फॉर्मूलास क्लास 11 के और क्लास 12 के पता होना चाहिए. So y equal to sin inverse of sin 2 theta will become by self-adjusting property 2 theta, and when x equals to tan theta, theta will be tan inverse of x. So 2 tan inverse x. Now we will differentiate the simplest form of it. dy by dx equals to 2 into d by dx of tan inverse of x, that is 2 upon 1 plus x square. If y equal to sin inverse of 1 minus x square upon 1 plus x square, find dy by dx. Here if we take x equals to tan theta, as we know in the class 11th, cos 2 theta is equals to 1 minus tan square theta upon 1 plus tan square theta. So we got it cos 2 theta, but cos 2 theta can be converted as sine in the form of a complementary angle, sine 90 minus theta and sine 90 minus theta. Here sine inverse of sine 90 minus theta will become 90 minus of 2 theta, 90 minus 2, and theta is tan inverse of x. So dy by dx differentiating with pi by 2 with respect to this constant value 0, and differentiation of 2 tan inverse x will be 2 upon 1 plus x square minus sin is there. Next question is y equals to tan inverse under root 1 plus x square minus 1 upon x, then find dy by dx. So here also 1 plus x square, if it is 1 plus x square, we take x equals to tan theta. As we know that in class 10, second identity, 1 plus tan square theta is sec square theta. So 1 plus tan square theta sec square theta ka square root sec theta minus 1 upon tan theta. Sec theta can be written as 1 by cos theta minus 1 and this tan theta sine upon cos. After taking LCM we get tan inverse of 1 minus cos theta upon sine theta. And 1 minus cos theta is 2 sine square theta by 2. So here it is 2 sine square theta by 2 and sine theta is 2 sine theta by 2 cos theta by 2. 2 and 2 cancel, 1 of the sine theta by 2 cancel. So sine theta by 2 upon cos theta by 2 is tan theta by 2 and tan inverse of tan theta by 2 will give us theta by 2 and theta is tan inverse of x. So 1 by 2 tan inverse of x. After getting the simplest form, now we will differentiate it. dy by dx is equals to 1 upon 2 into 1 plus x square. Next question is, if y equals to tan inverse of 1 plus x upon 1 minus x. अगर अपन 1 को x मान लेते हैं और x को y, तो हमारा फॉर्मूला क्या बनेगा? tan inverse of 1 plus x upon 1 minus 1 into x equals to tan inverse of 1 plus tan inverse of x. मतलब ये फॉर्मूला किसका बन गया? tan inverse of x plus y upon 1 minus xy is equals to tan inverse of x plus tan inverse of y. So it can be written as, this can be written as d by dx of tan inverse of 1 plus d by dx of tan inverse of x. But this is a constant function, so it will differentiation will be 0 and d by dx of tan inverse of x is 1 upon 1 plus x square. Now here comes the next question. Y equal to tan inverse under root 1 plus x square plus under root 1 minus x square upon under root 1 plus x square minus under root 1 minus x square. Find dy by dx. Here we will take x square equals to cos 2 theta. 2 theta equal to cos inverse of x square and theta will be 1 by 2 cos inverse x square. As we substitute the value of x square cos 2 theta everywhere, 1 plus cos 2 theta is 2 cos square theta, 1 minus cos 2 theta is 2 sin square theta. So root over 2 cos square theta will be root 2 cos theta, root 2 sin theta, root 2 cos theta, root 2 sin theta. Root 2 will be cancelled out by taking common. Now we are here dividing the numerator and the denominator, all these terms with sin cos theta. So cos by cos 1, sin by cos tan, cos by cos 1, sin by cos tan. This tan inverse of 1 plus tan theta upon 1 minus tan theta, this can be written as in the form of tan a plus b by putting 1 equals to tan pi by 4 plus tan theta and 1 minus 1 into tan theta, tan pi by 4 into tan theta. So tan a plus b का फॉर्मूला हो गया tan a plus tan b upon 1 minus tan a tan b. So tan inverse of tan a plus b by self-adjusting property, the angle will be out pi by 4 plus theta. So pi by 4 and theta is 1 by 2 of cos inverse of x square. Now after converting them in the simplest form, we will differentiate it with respect to x. So dy by dx is equals to, this constant value differentiation will become 0 and this will become minus 1 by under root over 1 minus x square plus square, as we will take a function of function x square equals to t. So this becomes x to the power 4 and d by dx में d by dx of x square का differentiation 2x. This 2 and 2 will be cancelled out and left out with minus x upon under root over 1 minus x to the power 4. Next question is the important question. If y equals to sin inverse of 5x plus 12 under root over 1 minus x square upon 13. First we can split it out. 5x, 5 by 13 into x, 12 by 13 into under root 1 minus x square. This 5 by 13 I am going to take it as equal to sin alpha and this x I am going to take it as a cos beta. If sin alpha is 5 by 13, then cos alpha will be calculated as 12 by 13. If sin x equals to cos beta, then sin beta can be calculated with the help of the formula 1 minus cos square beta root over 1 minus cos square beta root over 1 minus x square. So in this place I am going to substitute their values now, whatever I have calculated here. 5 by 13 is our sin alpha, so sin alpha, and x cos beta. 12 by 13 is cos alpha, so cos alpha, and sin beta is under root 1 minus x square, so under root 1 minus x square की जगह में sin beta. So sin a plus b is equals to sin a cos b plus cos a sin b. So this becomes sin A plus B, that is sin alpha plus beta. So sin inverse of sin theta will be theta alpha plus beta. If we are going to take sin alpha is equals to 5 by 13, then alpha will be sin inverse of 5 by 13 and beta will be equals to cos inverse of x. Now after converting the simplest form, I am going to differentiate it with respect to x. So dy by dx equals to d by dx of sin inverse of 5 by 13, which is a constant value. So differentiation of constant is 0, and d by dx of cos inverse x is equals to minus 1 upon under root 1 minus x square. Now the next question, if y equals to cos inverse x minus x to the power minus 1 upon x plus x to the power minus 1, find dy by dx. So x to the power minus 1 can be written as 1 by x minus 1 by x plus 1 by x. So after LCM it becomes cos inverse of x square minus 1 upon x square plus 1. As we know that the formula for cos 2 theta is in the form of 1 minus x square upon 1 plus x square. तो x स्क्वायर प्लस 1 को 1 प्लस x स्क्वायर लिख सकते हैं, लेकिन x स्क्वायर माइनस 1 को मुझे 1 माइनस x स्क्वायर करने के लिए माइनस साइन करना होगा. सो cos इनवर्स ऑफ माइनस 1 माइनस x स्क्वायर अपॉन 1 प्लस x स्क्वायर एंड cos इनवर्स ऑफ माइनस ऑफ थीटा इज पाई माइनस cos इनवर्स ऑफ x. नाउ आई एम गोइंग टू टेक लेट x इक्वल्स टू tan थीटा, थीटा इक्वल टू tan इनवर्स ऑफ x, y equals to pi minus cos inverse of 1 minus tan square theta upon 1 plus tan square theta. This is the formula of cos 2 theta. Cos inverse of cos 2 theta is equals to 2 theta, so it becomes pi minus 2 theta. Now pi minus 2 tan inverse x is our theta. So 2 tan inverse x, differentiating with respect to x, dy by dx, this constant value pi will become differentiation 0, and d by dx of tan inverse x is 1 upon 1 plus x square. So final answer is here minus 2 upon 1 plus x square. Now the next question, this is also another important question. If y equals to sin inverse of under root 1 plus x minus under root 1 minus x upon 2, find dy by dx. As I told, wherever we are getting under root 1 plus x or 1 minus x, I substitute x equals to cos theta. So theta will be cos inverse x under root 1 plus cos theta minus under root 1 minus cos theta upon 2. 1 plus cos theta is 2 cos square theta by 2 and 1 minus cos theta is 2 sin square theta by 2. Here. So इसका स्क्वायर रूट लेंगे तो रूट 2 cos थीटा बाई 2, इसका स्क्वायर रूट लेंगे तो रूट 2 sin थीटा बाई 2. अब इस 2 को मैं अलग अलग सेपरेट डिवाइड कर रहा हूँ. रूट 2 बाई 2 cos थीटा बाई 2 माइनस रूट 2 बाई 2 sin थीटा बाई 2. रूट 2 अपॉन 2 विल बी 1 बाई रूट 2 cos थीटा बाई 2. हियर आल्सो 1 बाई रूट 2 sin थीटा बाई 2. अब यहाँ बाहर में sin इनवर्स है. आई विल मेक द फॉर्मूला फॉर sin a minus b as here it is a minus. So cos ऑलरेडी यहाँ है, तो आई विल टेक sin pi by 4, sin 45 degree, sin pi by 4 is 1 by root 2. Here I will take cos pi by 4 is also 1 by root 2. So sin a cos b minus cos a sin b will become equal to sin a minus b, sin pi by 4 minus theta by 2, and sin inverse of sin pi by 4 minus theta by 2 will become pi by 4 minus theta by 2 equal to pi by 4 minus 1 by 2 theta के स्थान पर सब्स्टिट्यूट करेंगे cos inverse of x. Now it is in the simplest form. Now we can differentiate it with respect to x. So dy by dx will be equals to d by dx of pi by 4 constant will be 0, and d by dx of minus 1 by 2 cos inverse x. Cos inverse x का डिफरेंशिएशन होता है minus 1 upon under root 1 minus x square. तो फॉर्मूला का माइनस ये वाला और डिफरेंशिएशन का माइनस हमारा प्लस हो गया, और फाइनल आंसर आ गया 1 upon 2 under root 1 minus x square. Now next question, if y equals to tan inverse 7x upon 1 minus x square, find dy by dx. We can adjust this function in the form of tan inverse of x plus y upon 1 minus xy. So 7x can be written as 4x plus 3x and 12x square can be written as 4x into 3x. So that it can become tan inverse of x plus y upon 1 minus xy, which is equals to tan inverse of x plus tan inverse of y. Therefore y is equals to tan inverse of 4x plus tan inverse of 3x. Now we can differentiate it with respect to x by taking function of function as 4x equals to here t and 3x equals to u. So to differentiate, we will get डी बाई डी एक्स ऑफ tan इनवर्स ऑफ x होता है 1/1 प्लस एक्स स्क्वायर, तो इसका स्क्वायर 1/1 प्लस 4x का स्क्वायर 16x स्क्वायर एंड डी बाई डी एक्स ऑफ 4x इज 4 प्लस डी बाई डी एक्स ऑफ tan इनवर्स ऑफ 3x का स्क्वायर 1/1 प्लस 3x का स्क्वायर 9x स्क्वायर एंड dt बाई डी एक्स में डी बाई डी एक्स ऑफ 3x हो जाएगा 3. If y equals to cos inverse of 1 minus 6x square upon 1 plus 6x square, find dy by dx. Now again it is in the form of 1 minus tan square theta upon 1 plus tan square theta. So root 6 का square root हो गया root 6 और x. So root 6x the whole square we can take it as 1 minus root 6x the whole square upon 1 plus root 6x the whole square. Now here if we can take root 6x equals to tan theta, so theta will become tan inverse of root 6x. So cos inverse of 1 minus tan square theta 1 plus tan square theta will become cos inverse of cos 2 theta which is equals to 2 theta and theta is our tan inverse of root 6x. So y equals to 2 tan inverse root 6x. Differentiating with respect to x now, 2 into d by dx of tan inverse root 6x, that will be 1/1 plus 6x square, ये 2 पहले से था और d by dx of root 6x will be root 6 only as d by dx of x is 1. So our final answer is 2 root 6 upon 1 plus 6x square. Now comes if y equals to sin inverse 2 to the power x plus 1, power में है x plus 1 पूरा upon 1 plus 4 to the power x. It is very important question and this question was asked in the CPSC also. Find dy by dx. Y equal to sin inverse of 2 to the power x plus 1 upon 1 plus 4 to the power x can be reduced by the loss of exponents 2 to the power x plus 1 as x to the power n plus n can be written as x to the power n into x to the power n. Therefore it can be written as 2 to the power x into 2 to the power 1 upon 1 plus this can be written as x to the power n to the power n is x to the power n into n. So this can be written as 2 to the power x to the power 2. 2 का square. Okay. Now let 2 to the power x equals to tan theta, theta equals to tan inverse of 2 to the power x. So now this function will be converted into the trigonometrical formula y equal to sin inverse of 2 tan theta upon 1 plus tan square theta. This is the formula of sin 2 theta. So sin inverse of sin 2 theta is 2 theta, 2 tan inverse of 2 to the power x. Now differentiating with respect to x, 2 into d by dx of tan inverse of 2 to the power x. As we take a function which is 2 to the power x equals to t. So d by dt of tan inverse of t 1 upon 1 plus t square. So 2 upon 1 plus t square 2 to the power x का square and dt by dx में differentiation होगा d by dx of 2 to the power x. As we know that d by dx of a to the power x is a to the power x log e a. So 2 to the power x log 2 to the base e. So 2 to the power x is 2, 2 to the power x plus 1 log e2 upon 1 plus 4 to the power x. That is our final answer. Now today I have solved 26 differentiation questions. एक बात मैं अच्छी तरीके से आपको समझा दूं हिंदी में कि ये सभी क्वेश्चंस को आपको प्रैक्टिस करना है. इसके अलावा अगर मैंने 26 क्वेश्चंस बनाए तो इसके 3 गुना क्वेश्चंस मतलब नियर अबाउट 70 to 80 क्वेश्चंस you have to practice in your fair notebook. These questions you have to write down in the fair notebook as well as you have to solve near about 70 to 80 questions of this format in your fair notebook. Afterwards there is no time to explain me again the complete differentiation chapter because time is too less for me. So जो और मैं ब्रॉडकास्टिंग चैनल के थ्रू से आप लोग को कुछ 25 to 30 questions of differentiation I will send you. That questions also you have to solve in your fair notebook. Whatever the topics I am teaching, from that topic only I will send you the questions through the broadcast channel. Please try to finish it out and if you are having any type of doubt, you can send me through the picture that particular question doubt that I can able to solve it. But if you are really having any doubt in that question, then only. Otherwise, please, otherwise my portion will be getting delayed. Okay, thank you to all.